This is the lesson 2.1 independent practice. This is page 35. And there's enough on this page that is probably going to get broken up. This page alone will probably get broken up into two videos. I'm thinking that we're going to do 5 through 18 on the first video, and then we'll do all the word problems on the next video. That's okay. We need a lot of practice on this. As always, you should be watching this video when you are ready to check your answers or if you need some hints. So 5 through 8 ask you to list the factors of each number, and this is simply you need to work carefully. Most kids get most of them, but if you leave any off, it is important to recognize that and then try not to make that same mistake in the future. Number 5 is 12. We've listed the factors of 12 several times. It's 1, 2, 3, 4, 6, and 12. If you don't have all 6 of those, you need to revise that. 50, there are 6 factors for 50 as well. It is 1, 2, 50 is an even number, so it's divisible by 2. 5 times 10, so 5 and 10 are both factors. 25 and 50. I want to point something out to you. When it comes to even numbers, the last factor is itself, and the second to last factor is exactly half of it. So for 12, it is an even number, so the last factor is 12. The second to last factor is half of 12, which is 6. That's true for all even numbers. So 50 is its own factor, and half of that is 25. That same thing that I just told you is going to work for number 8 as well. I think we're going to do that one real quick. We'll come back and do 7 last. Factors of 64, there are 8 of them. 1, 2, 4, 8. And now we've got the partners, and 8 is going to be its own partner, and I was wrong. It's going to be 7 factors. It's going to be 8 times 8. It's going to be 4 times 16, and I'm using the upside down rainbow method. It's going to be 2 times 32, and it's going to be 1 times 64. And again, I just pointed out to you, for all even numbers, the last factor is itself, and the second to last factor is half of it. All right, so check out the factors of 39. It's an odd number, and odd numbers almost always have less factors than even numbers because very commonly the second factor is 2. Well, the second factor of an odd number is not going to be 30. It's not going to be 2. It might be 3, and in this case it is. It's going to be 3 times 13, and it's going to be 1 times 39, and that's it. There's only 4 factors of 39. All right, so let's go ahead and check out the next set. I'm going to go ahead and move this up, and I'm going to create a whiteboard, and I may show my work once in a while on that. I'll just create a whiteboard right here. All right, so the directions read, find the greatest common factor of each pair of numbers. And it is okay to try these mentally. It is fine. Just when you do, fix anything that you got wrong. The ones that I think are pretty much easy enough to do mentally, I'll show you that. But the ones that you might miss, I'll show work. So number 9, I know that 40 and 8 are each divisible by 8, and that is the greatest common factor for 40 and 48. And for number 10, some kids are going to get, here's what I'll do. I'll move my whiteboard up right here. I'll just move it down as we go. For 30 and 45, a lot of kids are going to get 5 for this one, but I'm going to show you why it's not 5. The factors of 30 include 1 and 2 and 3, 5, 6, 10, 15, and 30. And the factors of 45 include 1, 3, 5, 9, 15, and 45. And so the greatest common factor there is 15. (10 and 45). I wonder if that one's a little bit obvious. Numbers that end in 0 and 5 are divisible by 5, and that is the greatest common factor of 10 and 45. And 25 and 90 is the same idea. Numbers that end in, let me show you why on number 12. Let me show you the quick way to do this. Factors of 25, there's only 3. 1, 5, and 25. So then for 90, do we need to list all those? No, what we need to do is we need to ask ourselves, is 25 going to be a factor of 90? In other words, does 25 go into 90? It does not. So now all we have to do is ask ourselves, does 5 go into 90? It doesn't really matter if 2 goes into 90. It does, but 2 can't be the answer. So I just got to ask myself, does 5 go into 90? And it does. And since 25 doesn't, then the answer has to be 5. So that's a logical reason how you can get an answer without actually checking all your factors. 21 and 40. This is almost a trick question. But, I mean, it's really not, but let me show you why the answer is 1 here. Factors of 21 include 1, 3, 7, and 21. Factors of 40 include 1, 2, 4, 5, 8, 10, 20, and 40. And if you examine both lists, you'll notice that there's not a 3 in the 40 list, there's not a 7 in the 40 list, there's not a 21 in the 40 list, there's not a 2 in the 21 list, there's not a 4. I could keep going all day. The greatest factor in both is 1. Sometimes the greatest common factor of two numbers is 1. Not always, not even often, but sometimes. Let's check out number 14. 28 and 70. And some kids get this one wrong because they say 7. And let me show you why it's not 7. Factors of 28 are 1 and 2 and 4 and 7 and 14 and 28. Remember what I said earlier about when it comes to even numbers, the last factor is itself and the second to last number is half of it. So you know 14 is a factor of 28, and then what you need to use a multiplication chart to check to see if 14 does go into 70, and it does. 5 times 14 is 70. And so what does that mean? Well, it means that 14 is in both lists. 14 is the greatest common factor of 28 and 70. So let's go ahead and move this up. We've got a couple more problems to do here. We're going to do these last 4 real quick, and then we'll switch videos for the word problems. All right, I don't know if this is mental math for all of you, but 60 and 72 share a factor of 12. That is the greatest common factor of those. 45 and 81 are each divisible by 9. That's the greatest common factor of those. 28 and 32, the greatest common factor is 4. And number 18, the greatest common factor is 11. Like I said earlier, if you got any of those wrong, just fix them to the best of your ability. Make sure you're practicing your factors so that you're getting all these right.